My name is Antalya. I am currently a fourth-year medical student at the University of Pittsburgh. I went to Hunter for high school, and then I went to NYU before moving out here to Pennsylvania. As Queller said, we've known each other for a long time. I've been doing a lot of Hunter tutoring, SHSAT tutoring, and tutoring in college courses as well. So, if you ever find that you need someone, I am here for you and your child. Let me just, as I'm talking, get my iPad set up, and then we can get right into it. The way that I want to do this is we're going to go through the questions from the math section. And while we do each question, I'm going to go over relevant concepts and any content review that you should know. Okay, so give me 1 second. I think my sister is even joining this just to say hello.
Easy. So Antalya, while you're getting your iPad set up, everybody, we're going to have Antalya's sister. She's going to wish everyone good luck. She's also a tutor at Queller Prep. So let's take this moment to do that. And Antalya, just let me know once I have the green light with your iPad, okay?
Sure. Mm-hmm.
Catherine, I'm making you co-host. You can wish everyone good luck. Tell them where you went to high school, where you went to college, and the good luck that you're offering them.
Hi, everyone. I hope everyone is going to have a super fun time with my amazing big sister. You guys are very lucky to have her because she actually tutored me and helped me get into Stuyvesant and NYU. I don't know where I'd be without Anta, as I like to call her. But you guys aren't her sister, so don't call her my nickname, okay? Call her Antalya. But otherwise, you guys are in amazing hands, and hopefully you guys join a class that Antalya will teach. So super exciting.
Wow, that's so beautiful. So we have two power sisters. Catherine is going to depart. She wanted to wish her big sister good luck with starting the math webinar for Hunter. Catherine attended Stuyvesant and NYU. Antalya is a graduate of Hunter College High School. She's in medical school right now. 4th year, right, Antalya? Correct? So I'm very excited. She's interviewing now. So this is a really exciting moment. Thank you so much for doing that, Catherine. Without further ado, Antalya, thank you. Everyone, I just want to remind you, we've already emailed you this exam. So please use this opportunity to also have the link. We've already sent this. This is Hunter Test 1. All right, I'm going to go back on mute.
All right, great. Thanks, Francis. Okay, admitting a few people here now, but I think everyone should see my screen. I'm going to try to go at a nice pace. Again, if you have any questions, definitely send it in the chat. Again, please try to refrain from unmuting. All right, so we're going to start with this first question here, and I'm just going to zoom in. When you get to these first questions on the math section, you'll find that they tend to be a lot easier than the ones that come later. And these types of questions, especially in the beginning, should be easy points. You should know how to do these like the back of your hand. And so sometimes there's some strategy that you can use so that you don't have to brute force doing a problem. So when I say brute force, if we're looking at number 48, that's the first one we're going to do. We have this number 24.6998 plus 5.6294. Now, if you wanted to, you could sit there, you can do the addition out, spend 3 minutes doing this problem, blah, 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 right? However, if you look at the answer choices, A, B, C, D, and E, they're not extremely close to one another, which means that you can do some educated guessing. And what I mean by that is, if you see the first number, 5 point whatever, it has to be at least 5 that you're adding to the other number, which is 24 point whatever. So automatically you know that your answer has to be greater than 24 plus 5, which is 29. Okay? And this kind of kicks out these two answers. All right. Then let's see, anything in the chat? Colors, please. Okay, we are going to incorporate some more colors. Okay, and then so we know, as I said, that this has to be greater than 29. And so we can look at the last three answers, C, D, and E. Now, if you look at the 10th place in the decimal, you'll see that you have 0.6 plus 0.6. And that already is going to give you an answer that is greater than 1. So the reason why I'm saying this is because this helps us cancel out or eliminate C, right? Because 29 plus 1.2 has to at least be greater than 29.3. So you're left with these two answers at the end. Okay. And now, again, if you look at the last digit in each one, the last digit should be equal to the addition of the last two digits here. Let me use a different color. Here, I'm using a blue around the 4 and around the 8. And you should know that 4 plus 8 is 12, right? Giving us a 2 in that last place. Okay. And so by this strategy, you have found that the answer is D. Okay. You know that 5 plus 24 is 29, can't be A or B. You know that 0.6 plus 0.6 is going to give you a number greater than 1, which when added to 29 is greater than 30. So you are left with either D or E. And then you can decide D based on that last digit. Yes, I'll make this screen bigger. Let's see if this is good for people. Okay. And we will so I'm answering some of the questions as I'm going through. We're gonna be doing the questions from this exam, and as the concepts come up, I will go through them. Okay, this first question is mostly a strategy one, because again, I know you all know how to add two numbers together. Okay, you just want to save time so that you can spend it on the more difficult questions that come up later. Okay. All right. Sorry there. Okay. So moving on to the second question. Again, another one where we can use strategy. Sorry, my iPad is acting up. 1 second. There we go. Okay. So
and everyone check the chat box. I just put a copy of the test in the chat box so that you have it as well. Okay, so you can either follow the screen or you can open the doc. Okay, go ahead.
Thank you. Alrighty. Okay. And then we have this next question, number 49. If the positive difference between 3.2 and 1.09 is multiplied by 0.47, the result is blank. Okay, so whenever you see a question like this, you should be writing down what they're telling you, right? As they tell it to you. So we have the positive difference. So whenever you hear difference, you have to think subtraction. So 3.2 minus 1.09, okay, and then multiplied by 0.47, okay, times 0.47. All right. So again, you can go out and do this subtraction and multiplication that will take some time. But again, if you look at the answer choices, they are far enough apart that doing a little estimation will help you a little estimation will help you a long way. So this squiggly sign is our indication that we're approximating. This is very similar to saying 3 minus 1 times 0.5, okay? And 0.5 we know is half. So 3 minus 1 times half is going to give us 1 times half. Oh, sorry, not 1 times half. It's going to give us 2 times half, which is 1. Okay? Alrighty. Can everyone see that? I don't know why. Okay.
Yep,
alrighty.
So far so good.
So far so good. Okay, great. So if the answer is going to be close to 1, we have B, right? Because C is above 1, D is definitely above 1, so is E, and A is basically 0.01, which is too small for us. So in this way, we have the answer B. Okay. Alrighty. And then let's move on to the next question. We have, what is the value of half divided by 8? So we know, right, that you always need to do your parentheses first when you have an expression. So let's see here. You have half divided by 1/8. And now whenever you're dividing fractions, you are really just doing the first value, or half, times the reciprocal of the second value, which is 8/1. Okay, so that gives us 4. 8 divided by 2 is 4. And then you can proceed with the second part of the equation. You have half divided by 4. Okay, and again, you're gonna use that reciprocal because you're multiplying and dividing fractions. So half times 1/4 is equal to 1/8. Okay, and so this should give us our answer of E, or 1/8. Okay, again, these types of questions are very easy points. Okay, you just have to memorize the formula. There's unfortunately no way around it. And you should be getting the right answer. Okay. All right. For 51, very similar. You just need to know how to do it. Okay. It's formula wise. Okay. So when they ask you for product, you are multiplying 3/4 times 5/12. Okay. Times 8/15. We can break it up into the first two. It doesn't, in this case, there's no parentheses that we're introducing, so you can do whatever order you would like. So let's make it easy, and let's start with these two guys, the 3/4 times 5/12. Okay. Each of the fractions each of the fractions are in its simplest form. So you can simplify them across. So what I mean by that is, you notice here that 3 and 12 are related. 3 is a factor of 12. So if you were to divide the top and bottom by 3, so 3 divided by 3 is 1. 12 divided by 3 is 4. Okay. And so this would give us 5 out of 16. Okay. And we're not done yet, right? We still have to multiply these two. So now we have 5/16 times 8/15. And again, we notice that the numbers diagonal from each other are related, right? 5 is a factor of 15. So we divide the top by 5, we get 1. We divide the bottom by 5, and we get 3. All right. Similarly, we see here that, let's use a different color. We see here that 8 is a factor of 16, right? And so we can do the same thing. 8 divided by 8 is 1. And then 16 divided by 8 is 2. So at the very end, you're left with 1/6. Okay. And you didn't have to do any of that tough work multiplying everything out, because you were able to simplify it. And so that should give you an answer of A. Okay. I'm just checking the chat to see if there's anything. Okay, great. Nothing yet. All right. Let's move on to the next page now. So going down again, 48 is D, 49 is B, 50 is E, and 51 is A. Okay. All right. So Hunter definitely loves its fraction and reciprocal questions. So as I zoom in here, whenever you see these stacked fractions, you are going to want to do them separately so that it's a little bit easier on you. Okay, so first we're going to do, let's start. We're going to divide it in two. We're going to start with this one, number 1, and this one, number 2. All right, so for number 1, again, I'm sure you all know this, but when you are subtracting two fractions, you have to make sure that they have the same denominator, right? So 2 is a factor of 4. So in order to bring it to 4, we're going to multiply the top and the bottom by 2. And what we should get is 14 over 4 minus 1 over 4. Okay, and that'll give us 13 over 4. And then now we can do the bottom. This one's a little trickier because 3 and 4 are not factors of each other. So a way to do that is to bring them to the same denominator. You would kind of multiply them by each other. So on the left fraction, 2/3, you can multiply the top and bottom by 4. And for the rightmost fraction, you can multiply the top and bottom by 3. And this makes sense because you would be getting 8/12, okay, minus 3 over 12, which is 5/12, okay? And so now you're left with 13 over 4 over 5 over 12, okay? And here we are again, we're dividing fractions. Okay, so I'm going to continue underneath here. This is just 13 over 4 times the reciprocal, so times 12 over 5. And again, this trick of being able to simplify the fractions across the equation is very important because it'll save you a lot of time. And so we see that 4 is a factor of 12, which means that we can divide, or sorry, we can divide by 4 from on the bottom and on the top. So here 4 divided by 4 is 1. Okay. Here 12 divided by 4 is 3. So we're really left with 13 times 3 over 1 times 5. And this is much easier, right? This should just be 39 over 5, which gives us the answer E. Okay, just admitting some more people now in case you need time to copy. All right, great. Okay. Please, please, please review your fractions, okay? And the rules. The dividing is maybe the most confusing one. Okay, I'm getting a question here saying they are confused. If you are confused, can you let me know in the chat what is confusing you? So while we wait for that, just to recap, we're splitting up this fraction into the topmost fraction, so number 1, and the bottom fraction, which is number 2. Okay, we're doing the subtraction. Okay, all right. 1 second. Okay. All right. Okay, so the part that's confusing I'm seeing here is the part where I turned 12. Okay, sure. All right. Let's talk about why this simplification is so important. So I'm going to backtrack. Thank you for the people in the chat who are letting me know that they're confused. You can use another way if it works for you. Okay, as long as you're getting the right answer, but this concept of simplifying is an important one. So let's see. Definitely, there's no way around the fact that when you're doing 13 over 4 divided by 5 over 12, it's going to be multiplied by the reciprocal, okay? And this works because what this is really saying is 13 times 12 over 4 times 5, okay? And so this, in other words, you can rewrite as 13 times 4 times 3 over 4 times 5. Okay, so I just broke up 12 into its factors, 4 times 3. And what I'm trying to say is whenever you have the same number in the numerator and the denominator and you're multiplying, you can cancel them out. Okay? Because 4 over 4 is just 1, right? Okay, screen a little smaller. Sorry about that, guys. Okay. So again, 4 over 4 is 1. You can just cancel that out. And this again leaves you with 39 over 5. Every time I'm doing this, I'm not, okay, when you divided the fractions, what is the easy, this is the easy way to do it. 1 second. All right. Okay. So when you're dividing fractions, it's always going to be the first fraction. Okay, let's do this. Let's use a formula. A over B divided by C over D is always going to be A over B times the reciprocal of C over D. So the reciprocal of C over D is just the reverse, it's the flip. So that's going to be D over C. And so that's what we did here, okay? A over B is our 13 over 4. And D over C is 12 over 5. Okay. Alrighty. Okay. And so then again, this is why we're doing our, just to go back to the canceling out, because I know it's a little bit confusing, but once you get it, it will save you so much. So my shortcut was to just cancel this and do the division by itself. So instead of writing 4 times 3 and writing like this, I know that 4 is a factor of 12. And so I just divide 12 by 4 to get 3. Okay. All right. Okay. We might get another one of these questions, but if not, definitely, if you don't, definitely, sign up to tutor, but you can also Google questions, dividing fractions, and get some practice doing this as well. Okay, number 53, we'll be moving on. Okay, I got a question in the chat asking if the actual Hunter test is easier than the prep or harder. Usually, it's good to do the hardest questions you can in prep. So if you do see tough questions, you know how to approach them. Sometimes on the real thing, they are harder, but the lessons that you learn in prep, you can apply them during the actual test and you can figure it out, okay? All right, so number 53. We're looking at the 185th digit in this pattern. Okay, so in this pattern, we see that we have all the numbers going until infinity, right? We don't know when it ends. We start with 1 through 9, which are numbers that are single digits. We have 9 digits total from 1 through 9, and the rest are 2-digit numbers, okay? And so the way I'd like to think about this is we already know we have 9 digits. So if we want the 185th digit, we want to know how many digits left over, how many digits there are left over that we need to account for, right? How many more digits aside from 9 do we need to care about? And so that should actually be 176. There are 176 digits after 9. So let me write that down. 176 digits after 9. And remember how I said that all of the digits after 9 are 2-digit numbers, right? You have 10, 11, 12, 30, 40, 50, so on and so forth. So how many numbers do we have after 9? So how many numbers? We know the digits, but not the numbers. Okay, so we're going to do 176 divided by 2, right? Because there are 2 digits in each number. And so that means we have 88 numbers after. Okay, so if we know we have the first 9 numbers, right, which are also 9 digits, plus the 88 numbers that come after. One second. Yep. Then we should have 97 as our last number. Okay. Because now we're talking numbers, not digits. And then if we're looking at this, we know that the 185th digit is going to be this 7 here. Okay. Let's see if there's anything in the chat. Okay, someone asked what it would be like if it were to go in the 100th place. Okay. In the hundreds place, okay, let's say someone asked, yeah, if you were to talk about numbers that go into the hundreds, you would divide it by, you would figure out how many numbers there are with 2 digits. So you would still do like your number divided by 2, but then if you have hundreds, everything after that, you would divide by 3. So it really depends which number digit they tell you. If they told you like the 1000th digit, then you can probably assume that you're going to be going into numbers that are hundreds. Okay. All right. And then let's see. I don't understand 53. How would you know if it's the second digit in the number? Great question. So let's see. Okay. Because you know that you have 107, this is the 176th digit. So sorry, that's actually not a good explanation. So you have 9 digits in the beginning, and then you found out that there are 88 numbers. And so the 88th number is 97. Okay. And so because we already know that 9 plus 176 is 185, then that means that last digit should be the last digit of the number. Okay. There's another way to think about this too. How did I get the 2? Okay, before I get there. So I got the 2 because in these numbers, if you think about it, 10, 11, 12, 13, there are 2 digits in each number. Okay, so you want to find out how many numbers there are to help you figure out what the last digit is. Then you know there are 88 numbers. This is really convenient because it starts at 1. You know, number 1 through 88, that's going to be the 88th number. So that's why we divide the 176 digits that we need to find because of this, because they tell us to, and divide it by 2 to figure out how many numbers. Okay. Any other questions for 53? Okay. We subtract. Okay, so Someone is asking why we subtract 9. So in the beginning, we find out there are 9 digits, okay? Here, each digit is one number, right? 1 is one number, 2 is one number, okay? That's different than 10, which is one number, but 2 digits, okay? So we know that the first 9 digits are the first 9 numbers, and we need to figure out how many digits there are after those 9. Okay. All right. And then someone is asking, can you review how the second digit in the number is the answer? Okay. So you know that there are, to my left here, let me use a different color. I'm going to use an orange, a star. To my left where the star is, you know there are 9 numbers to begin with, right? 9 numbers, those 9 digits. And then we have 88 numbers after that, which we found out here, okay? So the 97th number is 97, okay? The 97th number also happens to have the second digit being the 185th, okay? If you have more questions, maybe you can ask in class, ask another tutor, because we do have to move on. I want to get to everything. There is also an answer key at the end of this math section, so you can also take a look at their explanation, okay? It should be exactly the same, but maybe that'll help you understand better. Okay, we'll do number 54 now, and we'll get a move on. Okay, so Copycat charges 18 cents for the first copy and 12 cents for each additional copy. What is the greatest number of copies you can get for $3? Okay, so we see here that it's in cents, okay? And they're asking for $3. So the very first thing I want you guys to do is to convert $3 into cents, okay? There are 300 cents in $3, okay? And then you can make an equation, right? The first copy, no matter what, is 18 cents. And then you have 12 cents for each additional copy. So 18 plus 12x, okay? X is going to be the number of additional copies. Is equal to 300. Okay, we subtract both sides by 18. And we get 12x is equal to 282. Okay. Then you would divide both sides by 12 to isolate the x. Okay. And then you should be getting x is equal to 282 over 12. You'll notice that when you do this division, you get that the number of additional copies is x equals to 23.5. Okay, but you cannot have half of a copy. Okay, and so the greatest number that you can add, the greatest number of additional copies is actually just going to be 23. Okay, you might be tempted to say, oh, the answer is 23. It is not 23, right? Because you need to take into account that first copy, right? The first copy that cost 18 cents. So that's going to be 1 plus 23, which is 24. And that is the right answer. 54 is D. Okay, this one was pretty straightforward. Alrighty. Next one, number 55. We have Tim who has these scores. He has 82, 90, 78, and 100. If he wants an average of 90%, what must the average of Tim's next 2 tests be? Okay, so something you should know definitely are how averages works. I'm just going to put a little formula down here, but if we have 6 tests, it sounds like, right? He has 4 scores and he's taking 2 more. sorry, someone in the chat just answered. Number 54, maybe you can ask me after the session, but we have to move on. You would be setting up an equation, okay? 18 plus 12x equals 300. I can also send the notes after the webinar is done. Okay, 55. So we have average, we have 6 numbers. So A plus B plus C plus D plus E plus F, 1, 2, 3, that's 6, divided by 6 is going to give him an average of 90, okay? So what that means is in total, he's going to have 540 points, right? All these numbers added together, if we multiply both sides by 6, should be A plus B plus C plus D plus E plus F is 540, okay? We already know the first 4 exams. He has 82 plus 90 plus 78 plus 100, okay? Plus E plus F is equal to 540. You can, or not you can, you have to add all these guys together, and that will give you 350. Okay, I'm getting notes to shift the screen to the left. This is as left as it'll go. It looks cut off, but the 540 is just at the edge of my screen there. Okay, so 82 plus 90 plus 78 plus 100 is 350. Okay, plus E plus F is equal to 540. You can subtract 350 from both sides, and you will be getting E plus F is equal to 190. Okay, and here you do not have to figure out what E or F are, right? Because you just want an average. So if you know E plus F is equal to 90, sorry, not 90, 190. The average is going to be E plus F divided by 2 and 190 divided by 2. You are dividing both sides by 2. Okay, and the average of the 2 numbers or the average of the 2 tests has to be 190 over 2, which is 95. Yep, great. So that should be C. Again, definitely know your formula for average. Okay. All right, so to go over the answers, 52 is E, 53 is, oh, I didn't say, 53 is C, 54 is D, 55 is C. Okay. Now on to 56. Okay, Susan begins counting backward from 1298 by 4s, saying one number every 5 seconds. At the same time, Jim begins counting forward from 171 by 3s, saying one number every 5 seconds. What number will they say it both at the same time? Okay, so it does not matter that they're saying one number every 5 seconds because they're both saying it at the same time. They're both saying at the same rate. So this is just here to distract you. And honestly, we can ignore it. Okay. So the way to solve a problem like this, again, sorry, someone asked to go back to my work. I can send out, or maybe Francis can send out my work from this as well.
Yes. Let's keep moving forward because that's really important. Okay.
Sure. Okay, so for this problem, 1298, the way you would work with this is you would think about multiples, okay? And so they want you to find an answer that fits 1298 and 171. So what I mean by this is 171 is a multiple of 3. Okay. And that makes sense because that means the answer that you will meet also has to be a multiple of 3. Okay? And the reason we know this is because 1 plus 7 plus 1 is 9, which is divisible by 3. Okay? And then when we look at 1298, you see that it's actually not a multiple of 4, despite the fact that Susan is going by 4s. Okay, so 1298 is not a multiple of 4. And again, you guys should know your divisibility rules for 4. It's the last 2 digits have to be divisible by 4 in order for the entire number to be divisible by 4. And 98 divided by 4 is 24.5. So that does not work. Okay. So now the reason why you do this is because the answer needs to fulfill these criteria, right? The answer has to be a multiple of 3, and it can't be a multiple of 4 in the same way that 1298 is not. Okay. So we can go across and check first to see if the numbers are multiples of 3. So 640 is not because the digits add to 10. 644 is not because the digits add to 14. 648 is not either because the digits add to 18. Oh, sorry, excuse me. 648 is because the digits add up to 18. So that means it is divisible by 3. D is not because digits add up to 11. And for E, it is divisible by 3 because the digits add up to 15. Okay, then we need to consider the last 2 digits for this to see if it is a multiple of 4 or not. So 48 is a multiple of 4, okay, because 48 divided by 4 is 12. All right, so this can't be our answer, and we're left with E. You can also double check that 54 divided by 4 is not going to give you a whole number. Okay, so 56 is E. All right, 57. Gabe is taller than Helen. Helen is shorter than Iris. Iris is shorter than both Jack and Kaiko. Which of the following statements are true? Okay, so let's see. Okay, sorry. I was just reading the chat. 54. So whenever you have a question like this telling you that people are taller than other people or someone has more money than someone else, but they don't give you actual values, again, it's always good to really just write it out. So you know Gabe is taller than Helen, okay? Gabe is G, Helen is H. And then we know that Helen is shorter than Iris, okay? But that's the same thing as Iris is taller than Helen, right? And then lastly, that last sentence, it says Iris is shorter than both Jack and Kaiko. So if Iris is shorter than Jack and Kaiko, that's the same thing as saying Jack and Kaiko are taller than Iris, okay? So in reality, we don't really know who the tallest person is. We know Gabe is taller than Helen, and we know Iris is taller than Helen, but then we know Jack and Kaiko are taller than Iris, but there's no relative statement. We can't say that Iris is the tallest because we know that she's just taller than Helen, and Gabe also happens to be taller than Helen. It doesn't matter. So really what we're left with is E. Gabe, Jack, or Kaiko could all be the tallest person because there's no way to have those relative terms. And it's really helpful if you just convert it so that sign is the same direction so you can really understand what they're trying to say here. Okay. And then we have number 58. it takes 24 feet of fence to surround a square piece of land. Okay, so automatically off the bat, this question is telling us that 24 feet is the perimeter. Okay. Now, Linda wants to plant flowers everywhere, but on a diagonal sidewalk. Okay. Note that there is 1 foot of sidewalk along 2 sides of the squares. Indicate in the diagram what is the area of the sidewalk. Okay. The way that I like to do this is I think it's easiest to figure out the area of the entire square and the area of the triangles inside the square, and then subtract those two to get the diagonal. So first we'll start. We know that because this is a square, all sides are equal. Okay. So in order to get one side of the square, that's going to be 24 feet divided by 4 sides, which is 6 feet. Okay, then we can write in our little square that each side is 6. Okay. And then we know now that we can find out the area of the entire thing. So 6 times 6 is 36 feet squared, or the total area. Okay. And now let's find the area of the triangles. The area of a triangle, you should know, is half times base times height. Okay. So you have half times 6 times 6, which is 36 over 2, or 18. Okay. And now we're going to do the same thing in this triangle, except the dimensions are a little bit different, right? We know that one side is 6 feet, but this side has that little piece of that walkway. So each side is going to be 6 minus 1, or 5 feet. Okay, so we have 5 and 5 here. And then, again, we're solving for the area of this triangle towards the bottom. So it's half times 5 times 5, which is 25 over 2, or 12.5. Okay. And so now what we're going to do is we're going to take the total area, which is 36. So that's the area of the whole square. And then we're going to subtract the area of that bit, the triangle on the left, the top triangle, plus the area of the triangle on the bottom. Okay, and that should just be 36 minus 30.5, which will give you 5.5, and that should be B. Okay, the area left over is the area of that little walkway. Okay. All right. Okay, to just go over, we have 56 is E, 57 is E, and 58 is B, 5.5. I'm getting a question here. Should you always convert from the fraction? I guess in this question, you should be, I think for easy fractions, you should be able to go between them, right? You should know that half is 0.5, that a quarter is 0.25, and so on. Definitely you can make a sheet for yourself and just write out the common fractions, maybe from 1 to 1/10, and then just memorize them so that you know them right off the bat what they could be. So you can go from like 5.5, or sorry, 5.5 to 5.5 and things like that. Okay. Okay. All right. Okay, on to 59. All right. Okay. When the 69th even natural number is subtracted from the 119th odd natural number, what is the result? Okay. So all even numbers, as we know, end in 2, 4, 6, or 8. Okay. So in order to find the 69th even number, so 69th even number, we're going to multiply 69 by 2. Okay. Because even numbers go up by 2. Okay. By 2, by 2, by 2. So you're going to do 69 times 2 to get 138. All right. And then we need to find out, let's see, we need to find out the 119th odd number. So the 119th odd number. Okay. And we know that as they tell us, the natural numbers start with the odd number 1, right? So you will, when you consider the first 119 numbers, like 1, 2, 3, 4, 5, you're going to start with that odd number, and you're going to have 119 odd numbers total. Okay. And then in between, you're going to have your even numbers. Okay. So you're going to have 118 even numbers in between, because it's being sandwiched in by the odd numbers. By the time you get to the 119th odd number, you're going to have the evens in between. It's essentially saying, like, it's very similar to saying that you would just multiply each one by 2. But in this case, you have to think about the fact that there are a certain number of odd numbers, 119 of them, 1, 3, 5, 7, 9. There's 119 odd numbers, but you have to account for the even numbers in between them, okay, in order to get to that final number. So you're going to add them, and you're going to get 237. Okay, 237 is the 119th odd number. And then at the end, you're just going to subtract them. 237 minus 138, and you will get 99. Okay. Just checking the chat to see if there's anything. Okay. Alrighty. And then we have number 60. What is the smallest prime number that can be written as the sum of 3 different prime numbers? Okay. So what is a prime number? A prime number is a number that can only be divisible by 1 in itself, can only be divisible by 1 and itself. So again, we have some prime numbers that we know off the top of our head that we can list. Let's say there's 2, 2 is a prime number. There's 3, there's 5, there's 7, and let's say 11 too, right? These are all prime numbers. And so let's see, we want to find an answer that's a prime number that can be written by adding 3 of these numbers up. So A of 10 is automatically taken out because it's not a prime number, right? 5 times 2 is 10, 10 times 1 is 10. So it's not a prime number. Same with 15, right? It's 3 times 5 is 15. So it's not only divisible by 1 in itself. Okay, then we're left with C, D, and E. And with this type of question, you have to try it out a little. There's no like right or wrong way to do it. It's trial by numbers. Someone asked if prime numbers are infinite. I'm actually not sure if they are infinite. I'll have to look that up later. Okay. And so after you play with a bunch of combinations for this question, you'll find that 3 plus 5 plus 11, so 3 plus 5 plus 11 gives you the smallest prime number that you can possibly get, and that would be 19, or D. Okay. All right, on to number 61. If you have 6 people in a room and each person shakes hands with every other person exactly once, how many total handshakes happen? So, okay. So I'm getting some questions about 60. So really quick before we move on to 61. You don't have to use all the numbers in order to find the sum. You just pick 3 numbers from that list. Okay. Let me see. I'm just going to admit some people in the waiting room. Yeah, it can be any 3 numbers from this prime number list. Okay. And 7 is a prime number, yes, but it doesn't, in the combination, it doesn't add up to the smallest prime number. Okay, 1 second. I just want to double check that the answer is 19. Yep. Okay. Yep. The answer is 19 to number 60. Okay. Sorry. I got an answer in a message in the chat saying. Okay. Alrighty. So we're going to go back to 61. Again, if you have questions, I will be sending these notes out. And 1 is not a prime number. Okay. To whoever said that in the chat, everybody, 1 is not a prime number. Okay. Alrighty. If you have 6 people in a room and each person shakes their hand with every other person exactly once, how many total handshakes happen? Okay, so these types of questions are asking, these are called combination questions. Like how many, let me write this down. How many unique combinations can be made from a total set? Okay, so this would be, there's a formula for this, and this is just something that, you'll need to know. In the answer key, I think it goes through a very convoluted way to describe how to do that, but it's really just a lot easier if you follow the formula. And so let's see here. So the formula is going to be n, little n, big C, little r is equal to n factorial over r factorial times n minus r factorial. Okay. Yes, you will need to know about factorials for this exam. Okay. And so if you were to plug this in, our question wants us to make unique combinations of 2 from a total set of 6. So what that means is we have our total set of 6, big C, and our number of combinations. We want 2 because 2 people are shaking hands. Okay. So if we plug this into the formula, we have 6 factorial over 2 factorial times 6 minus 2 factorial. Okay. And for those of you who may not remember, a factorial is essentially like 6 factorial is basically 6 times 5 times 4 times 3 times 2 times 1. And if you were to have 3 factorial, that would just be 3 times 2 times 1. Okay. Alrighty. And so here you would get 6 factorial over 2 factorial times 4 factorial. Okay. And the way you would break this up, I'm going to erase this and put it on the bottom. 6 factorial is just 6 times 5 times 4 factorial. Okay. Over 2 factorial, which is just 2, right? 2 times 1 is 2. And then times 4 factorial. Okay. And then that is just, you can cancel out the top and bottom, right? 4 factorial over 4 factorial is just equal to 1. And then here, I'm getting questions to zoom out. And this would just be 30 divided by 2 or 15. Okay. All right, so definitely memorize this formula for the test and know how to use them. Okay, I got 2 factorial. Okay, look at the formula, right? N is 6. Okay, because we have 6 people in the room. R is 2 because it takes 2 people to shake hands. Okay, and then you have N factorial, we know N is 6, R factorial, R is 2. And then you just plug it into the formula, do the subtraction, and then divide it out, okay? For those of you who do not know what a factorial is, I unfortunately don't have time to really delve into it. Again, a factorial is essentially multiplying all the numbers that come before it by that number. So like I said, like 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So again, please review that in your own time, okay? I'm going to leave this page up. We're just going to take a 2-minute break. Okay, well, I'll start again at 7:06. And I'll be admitting people from the waiting room while we do that.
And Talia, I'm just quickly checking in. Do you need anything? You're okay?
I'm good. We're taking our break. We have 1 more minute left.
Okay, perfect. Okay, I'm just gonna stay on mute.
Sounds good.
Can you make the screen larger? Let me just see it, just so it's bigger.
Okay.
Good. And when you're writing, can you use a thicker font? Is that possible?
A thicker,
Like a thicker pen?
Okay.
And if you could highlight also, you have the highlight option,
Yeah, I
right?
have a highlighter. Yeah, I can highlight more
Okay.
for this set. Thank you.
Yeah, that would be great. So let me see the font.
Oh, like here. Did it
Yeah,
work?
yeah, that's
Thicker?
much better. Yeah,
Yeah.
that's better. That's good. It's a nice thicker font and we can highlight. Perfect.
Okay.
Okay, so they're getting back.
Yeah, they should be getting back. Hopefully everybody's back. We're going to be moving on, okay? I know some of these
Yeah.
math problems are tough, but that's why you need to practice them, okay? So you can notice the patterns. All right, we're going to start with number 62, okay? We have the shape. The dots are spaced 1 unit apart, horizontally and vertically, okay? what is the number of square units enclosed by the solid line? So they're asking you to get an area, right? But you can save yourself so much trouble if you just notice that if you were to slide this one to the left 2 spaces and this one to the left 2 spaces, you would really just get, let's see how I draw here. You would really just get a rectangle, okay? That's 1, 2, 3 units long and 2 units wide, okay? So that's just 3 times 2, sorry. 3 times 2 is your area, which is 6. Okay, so your answer should be B, 6. Okay. Number 63. I'm getting questions in the chat asking if these tests are harder or easier than the real thing. This is a real Hunter exam that was given, I think a number of years ago. So someone somewhere had gotten these questions before, okay? So definitely review what we are going through today. Okay, now number 63. In the expression below, each letter represents a 1-digit number. Where the same letter appears, it represents the same number in each case. Each distinct letter represents a different number. In order to make the equation true, what must replace C? Okay, so this A, excuse me, that I'm highlighting is in the hundredths place. Okay, so we know that we are going to be working with 3 numbers that when you add them together give you something a little bit greater than 2,000. Okay, so you can, you'll have to like do a little bit of trial and error. Okay, so you can like guess, okay, maybe A is 4. If A is 4, that would mean 400 plus 400 plus 400 is 1,200, right? That's just 400 times 4. 400 times 3. So that's too small. That's not close to 2,000. So you can guesstimate a different set of numbers. Okay, so let's just try 6 because, off the top of your head, 600 times 3 is 180. Sorry, not 180, 1,800. Okay, and that's pretty close to 2012. So in this way, we can say that A is definitely 6. Okay, so now we know that A is 6, because if A were to be 7, 700 times 3 is 2,100, which is too big. Okay, so once we know that A is 6, we can go on our left here and we can rewrite, okay? So we know that 6, 6, 6 plus 6, 6b plus 6bc is going to give us some number, okay? We can pretend that b and bc are 0, right? Because again, this is going to give us a good ballpark to figure out what the other numbers are. So if we pretend, so here I'll write this, pretend B and C are 0. And so when we do that, we get 6, 6, 6 plus 6, 6, 0 plus 6, 0, 0. And we get 1926. Okay. So what this tells us is that the difference between 2012, so our original value, and 1926, okay, which is 86, that difference should be equal to BC plus B, okay? Because we pretended that B and C were 0 to kind of figure out what that difference between 2012 and 1926 would be. And then you would go on to, again, now you can trial and error some values. I'll just, you can try 8, 80, and, again, I set C for 0 because we don't know. So like let's just say C is 0. We're pretending again. If you had 80 plus 8, that would be 88, which is too big. That is bigger than 86. So that means B cannot be 8. So you can try B being 7. Okay, so 7 blah plus 7 is going to give you 86, which will make C 9, right? Because 79 plus 7 is 86. And so that will give you your overall answer of E9. Okay. All right. Again, when you get to questions like this, try your best not to panic and just write down things you know, okay? It's okay to make estimates sometimes because that will help you get to the answer. Okay. Now number 64. Excuse me. 15 people received an email and sent it to 3 different friends each, who in turn each sent it to 2 new people. What percent of the total number of people who received the email are the original 15? Okay. So we want to know how many people in total received any email, right? So we do know that 15 people first got this email. And then these 15 people sent it to 3 more people each, right? So that'll be 15 times 3, which is 45. And then those 45 people sent it to 2 people each. So 45 times 2 is 90, okay? And now the total number of people who got this email is going to be 15 plus 45 plus 90, or 150. Okay, alrighty. And then it asks us what percent of the total are the original 15. So we know we have 150 total. So 15 divided by 150 is equal to 10%. Okay? And that answer is B.
This sounds like one of my phone conversations. 5 people told 10 people, right? Isn't that so funny? Everyone, I want you to also take a look at the question. Do you notice how you can, can you just quickly zoom? I just want everyone to take a good look at this question.
Sure.
It's always a good idea to circle the last 2 words of the question, okay? So if you can do that, Antalya, circle those last 2 words, or last, let's do
Sure.
last 3 words. Let's
Yeah.
do the last 3 words. Let's actually circle it just because I really want to make sure that that's like popping out. So notice how easy it is to read this question, and at some point you stop and you're like, I'm done, but you're not done. So the original amount of people is what the question's asking. Does everyone see that? So the original was 15. Now out of a total. So it's really important. Always keep in mind what is the actual question. So if you could even write it down, like don't stop reading the question. Like read the last 3 words of every question. Can you actually write that or type it? Read the last 3 words of every question like 2 times. Because it's so easy to stop reading and to be like, oh, I see the answer.
Great. Thank you. Thank you for
All
the
right, go ahead.
pointer. All right. Yes, definitely make sure you're reading the question closely, okay? Because they definitely have answer choices that are red herrings, or ones that, they want people to pick because maybe they misread a detail, okay? All righty. And then we have 65. So this is actually describing a common commute some of my friends had to Hunter. Okay, so Susan is traveling from Queens to Staten Island via Manhattan. Or I guess not from Hunter. Okay. This Susan is just going very far, it looks like. Okay. So there are 3 different trains to get her from home in Queens. So we're gonna call Queens Q to Times Square. There's let's see, 3 trains. Right? So we can highlight that too, 3 different trains. Okay. And then from Times Square or TS, there are 5 trains to the Staten Island Ferry. So we're going to call that SIF for Staten Island Ferry. All right. And then we have 2 buses that run from the Staten Island Ferry to her home in Staten Island. Okay. So again, that is the home in Staten Island. So we're going to just call that home. And there are 2 buses. Okay. So how many different ways can Susan get from Queens to her home by train and bus if she's passing through Times Square and the, Staten Island Ferry? Okay. So this is a common question you will get. You will just have to multiply each mode of transportation by each other. Okay. So that's just 3 times 5 times 2 to get all the different combinations, and that is going to be 30. Okay. Alrighty. Number 66. Sam sold his bike to Susie for 35% more than he paid for it. Susie then sold the bike to Stanley for 20% more than she paid for it. We want the original price. So this is a good time to circle this last part. Okay, we want to know how much the percent of the original price that Stanley paid. Okay, so with this, we're going to pick a random number. Okay, that is going to let it be easier for us to figure out this percentage. So whenever you're seeing percents, a good random number to just pick is 100. Okay, so let's say the bike, so we're going to write here, use random value, and we want to keep it easy. Okay, don't make it harder for yourselves. Okay, so let's say the bike originally was $100. Okay, so then it was sold to Susie for 35% more than Sam paid for it, right? So sold to Susie. Okay. And so when I like to do these questions, I like to rewrite this in percentages. So if he's paying 35% more, that means that they're paying 135% of the original price. Okay, so that's the same thing as saying 135% is equal to 1.35. Okay, so 100 times 1.35, the original amount, which, you know, is an easy number. It's just $135 because 35% of 100 is just 35. So you get this value, and then you see that this bike at $135, Susie sold to Stanley. I'm just going to call him Stan. So that's going to be 135 times now 120%, right? Because it's 20% more than the original price. Okay, and in this case, this original price is $135. Okay, so 135 times 1.20, okay, which is going to give you $162. Okay, and then going back to the last sentence of the question, what percent of the original price did Stanley pay for the bike? So Stanley's paying $162. And we know that the original price was $100. So that's going to be 162% more. Okay, 162 over 100 is 162% or 1.62. Okay, make sure that you're able to convert between these fractions and percentages. Okay, and then the answer would be D, 162%.
And see how those last few questions are the ones that we're highlighting? So it's not about figuring out the first two sentences. It's that last piece. What's the original price? Did Stanley pay? Sam, the answer is Sam is very intelligent. Susie is super intelligent. Nobody wants to be friends with Stanley. All right, so this is the answer. But the bottom line is, look at those last three words. Can you just, or maybe four, pay for the bike. So that's really what you want to emphasize. Look at those last few words, pay for the bike. That's the original, goal. Your goal is to get that piece. So make sure you if you could even write this, take your answers to the finish line. Make sure you read all the way to the end to understand what's going on. Okay, I'm going to go back on mute.
Okay, thank you. All right. And then we have 67. Ella spent her whole allowance of $2 plus the 16 cents she had left over from last week on bubble gum. If the pieces of gum had been a penny cheaper, she would have received 3 more pieces than she did. How many pieces did she actually buy? Okay, so with this kind of question, if you were to do it algebraically, it actually would be very difficult and beyond your level. So the suggestion is to go through the answer choices and pick one or pick a few so you can try it out to see how many pieces and work backwards. Okay, so let's say, okay, first, we know that her allowance is $2 plus 16 cents. Okay, so let's convert that to cents so it's easier for everyone. Okay, so $2.16 is going to be 216 cents. Okay, and then we don't know the best place to start from here, so we're going to go backwards. So to me, I'll just pick, just looking at this, I'll pick 24 because actually of all these, 216 is divisible by 24, which makes it easier for us to help figure it out since we're working backwards. So let me write here that we are working backwards for this one. Okay. And we know that if she bought 24 pieces, let's say she bought 24 pieces, that means each piece will be 216 divided by 24, which is 9 cents per piece. Okay. And now the second part of the question tells us if the pieces of gum had been a penny cheaper, she would have received 3 more pieces than she did. Okay, so if it was a penny cheaper, it would be 8 cents, right? And then she could have gotten 3 more pieces. So if each piece is 8 cents, that means that means she could have gotten, let's see. That means her total would be 24 pieces times 8 cents. Okay. I'm trying to figure out how much money she would have paid if she bought the same 24 pieces. Okay. And that would be 192. Okay. She would pay 192 cents. Now, the money that she would have left over is 216 minus 192, which is 24 cents. Okay. And now with this leftover money, if we know that in this case, it's 8 cents a piece. 24 cents divided by 8 cents. Let me write this a little neater. 24 cents divided by 8 cents is those 3 pieces that the question is talking about. So basically, if we work backwards, we can see that if she buys 24 pieces, it's 9 cents a piece. But if the price had been 8 cents a piece, she could have gotten 3 additional pieces with that extra 24 cents that she would have saved. Okay. All right. Okay, moving on. Okay. For this one, this question takes some time, but the only way to do it is by counting. Okay, you just need to count. Okay. Okay. So I'm going to count for you, and then you can go home and look at this over again. Okay. So we're going to start first with the smallest squares or smallest 4-sided figures. Okay. It doesn't matter. It could be a square or rectangle in this case. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. I'm counting 8 as this rectangle. Okay, the smaller rectangle. 9, 10. Okay, so you have 10 of those smallest 4-sided figures. Okay, it's going to get a little tricky. And then we have 1, or let's call this 11. 11. And then we have 12. Okay, 12 is the smaller one and the middle one on the bottom. And then 13 is going to be this whole thing, this whole rectangle here, 13. Okay, then we're going to move to the left. We did everything in this tall rectangle. Then we're going to move to the left. Then we have 4, this guy. I mean, sorry, not 4, 14. And then we have 15, this longer guy. And then we have 16. Okay, 14, 15, 16. And then let's do a different color so we can see what's going on. Let's do pink. And then we have 17. Okay. And then we have 18. Okay, 17, 18. And then we have this whole thing, 19. Okay. And then now we can continue to move to the left. We have this big one. Okay, that's 20. Then we have this rectangle, 21. We have this one, 22. And then let's move to purple. Then we have some other rectangles going on in here. 23. And then we have 24. And then we have, what was that? That was 23, 24 in purple. And the last one, the grand finale, is this dark green. Is this 25? Okay. So your answer comes out to D, 25. Okay. Alrighty. We'll move on to 69. If a photo measuring 4 by 4 is placed in a photo frame that is 2 inches wide all around, what percent of the framed photo is the photo itself? Okay, so we're going to start off by drawing the photo. Okay, so we know it's 4 by 6. And then we know that we have a photo frame that is 2 inches all around. So 2, 2, 2, 2, 2, 2, and finally 2, 2. This is our photo frame. Okay, so we need to find the area of the photo and the area of the frame. So the area of the photo is easy, right? It's 6 times 4, which is 24. Okay, so we can put that in here. And then we have to find the area of the frame. So if we know here, or we know here that the width is 4, that we knew from the picture, plus the 2, plus the 2, okay? And that is 8. And we do the same thing for the other side, right? We have 2 plus 6 plus 2, which is 10. So that's going to give us an area of 8 times 10, which is 80. And that's going to be 24 over 80. If we simplify it, that should just be 3/10. You divide the top and bottom by 8. Divide by 8, divide by 8. And you should get 3/10 or 30%. Okay. 70. Steve, Jerry, and Ron were paid $29.25 to remove garden gnomes. They each worked 4 hours except for Ron, who was 45 minutes late. How much of the $29.25 should Ron receive? Okay, so again, we're going to convert our dollars into cents. We have $29.25 is equal to 2,925 cents. Okay, we know that there are 100 cents in a dollar, and that's why. We know then that Steve and Jerry worked 4 hours. Okay, and that is, we'll convert it to minutes because, you know, they tell us that Ron is 45 minutes late, so it's easier to convert to minutes. 4 hours times 60 minutes is 240 minutes total. Okay, Ron was 45 minutes late, so that means Ron worked 45 minutes less than Steve and Jerry. So that's just going to be 240 minus 45, which is 195. Okay. And then we'll need to find the total number of minutes that everyone worked so that they could divide it. They could divide the number of cents by the number of minutes worked. So let's see here. We know that 2 people each worked 240 minutes. Okay. If you have your camera on, please turn it off. Okay. Plus 195. Okay, sorry. 240 minutes is Steve and Jerry, both of them. That's why you multiply it by 2. 195 is Ron. And so that should give you 675 minutes total. Okay. And then you can solve for how many cents that they get per minute. Okay. 2,925 cents over 675 minutes. Okay, is 4 1/3 cents per minute. Okay. And now they're asking how much of the 29.25 should Ron get? Okay, we know that Ron worked 195 minutes. You multiply it by 4 1/3. Okay. And you should end up getting $8.45. Sorry, 845 cents. Because we're still in cents, which is just $8.45. Okay. Right, we are running out of time here, so I'm gonna speed through these guys. Okay, 71. In the diagram, all the angles that are shown are right angles. The length of AB is 4 and BC is 5 as indicated. What is the perimeter? Okay, so this is another one of those questions where you have to kind of look at the shape and see how the sides are related. Okay, so if you were to look at this right-hand side where I'm drawing my arrow, that length, or all of these lengths, are the same as 4. Like if you were to add up all these small little sides, they would all add up to 4. Okay. Same thing on the other side. If you took these small lengths, they would all add up to 5. Okay. And then you would essentially just do kind of like a perimeter, because this is what you have. So this is 4 plus 4 plus 5 plus 5, which is 18, or C. Okay, this one, you just have to go through the choices. There's no way around it. Name the 4-digit number ABCD that satisfies all of the following conditions. ABCD are the numbers 6, 7, 8, and 9, each used once. So already that takes us out of A, because that doesn't have 9. Okay. So that first condition, I, is not satisfied. We go to the second condition, CD forms a 2-digit number divisible by 4. Okay. Let's see here. So like I said, know your divisibility rules. For 4, the last 2 digits have to be divisible by 4 in order for the entire number to be divisible by 4. So I'll write that here. Last 2 digits must be divisible. Okay. So 96 divided by 4 works. So I'm just going to write that the second condition is satisfied. 76 divided by 4 also works. I'm writing that the second condition works for C as well. And then for 68 is also divisible by 4. So this one works as well. And for E, we already talked about how 76 is divisible by 4. Okay, so now we have to go to 3. BCD forms a 3-digit number divisible by 3. Again, BCD, so like 896, 976, 768, 876. Okay, so what we have to do is add it up and see if it's a number that's divisible by 3. Okay, so we have 8 plus 9 plus 6, which is 23, and therefore not divisible by 3, right? 23 is a prime number. Then we have 9 plus 7 plus 6, and that's 22. Again, not divisible by 3. Then we have 7 plus 6 plus 8, that is 21, so that is divisible by 3. And then we have 8 plus 7 plus 6, which is also 21, so that's divisible. Okay, and then you need to see whether A, B, C, D is divisible by 11. I think it's easier to actually divide by 11 than to use, I think the rule is like some wacky one involving like alternating digits. So I would just divide by 11, right? And we can pick D since D is right here. And we will get, actually, I'm not going to write this out. We will get that 9768 is divisible by 11. And you can just do the long division. Okay. And that's how you get to that answer. All right, number 73. Every kid in the 6th grade at PS 500 must read exactly 3 of the principal's 4 favorite books. If 34 read Math for Fun, 36 read Everyone Loves Math, 38 read Cool Math, and 12 read Math for Me, how many students? So we are looking at the total number of students in the 6th grade at this public school. Okay, so we know, because the question tells us that each student, okay, we know that each student reads 3 books. Each kid reads 3 books. Okay. And then we need to know how many total books were read. So 34 plus 36 plus 38 plus 12 is equal to 120 books. Sorry. 120 total books read. Okay. And then we know that each student must read 3 books, right? So we would just divide the total number of books by how many books each kid needs to read to figure out that there are 40 kids in the 6th grade. Okay. And that answer is B. Okay. We're going to move on. Number 74. There are 12 round gold medals, each with a radius of 3 inches, that just fit inside a box with 4 medals in each of 3 rows. A red tape fits snugly around the sides. What is the length of the tape? Okay, this is another one where you can kind of translate out the sides. And so they tell you that the radius is 3 inches, okay? So in these circles, you can draw in that radius, 3, okay? Each one has a radius of 3. And then, if you notice, the diameter of the circle, so the radius is 3, the diameter is just 2 times the radius, right? It just goes across the whole circle through the center, the diameter. So that's just going to be 2 times 3 is 6. Okay. So, and you see here that you have basically 6, 6, 6, 6, 6. So the length here is 6 times 4 is 24. And similarly in the width, you have 6, 6, 6, and you know this from the diameter being 6, which is 6 times 3 is 18. Okay, and then what is the question asking you, right? The question, let's highlight it and underline it. The question is asking you, yeah, sure. The question is asking, what is the length of the tape? Oh, sorry. What is the length of the tape? Okay, so the length of the tape is just the black line around all of them. So the length of the tape, what they're looking for is the perimeter. Okay. So the perimeter is basically all the sides of that rectangle added together. So it's going to be 18 plus 18 plus 24 plus 24, which is 84. Okay. And someone asked how you would define the radius and diameter. The radius is a line that passes from the center of the circle to the edge of the circle, while the diameter is a line that passes from one edge of the circle to the other edge of the circle, but must pass through the center as well. Okay, so if we have a circle, oh, that is a square, not a circle. If we have a circle, this is its center, this red dot. This is the radius, okay? And this, if I can draw a little bit better, this is the diameter, okay? The diameter is twice the radius. Okay. And we have 75. Two missiles are initially 5,000 miles apart. They travel along a straight line directly towards one another, one traveling at 2,000 miles per hour and the other at 1,000. How many miles are they apart? Sorry, how many miles apart are they 1 minute before impact? So we are going to first find out how long does it take them to impact? How long does it take them to hit each other? Okay. And the reason why we're doing that is because, let's see if we can draw here. If we have one coming in this direction at 2,000 miles per hour and one coming from this direction at 1,000 miles per hour, that means that when they hit, when they meet and hit, they will have covered a total of 5,000 miles, right? Because we know that they're 5,000 miles apart. So we're going to first answer the question, how long does it take to impact? And then we're going to set X equal to our hours. We're going to write an equation. Okay, 2,000 miles in 1 hour times, we don't know the time, right? We're trying to figure out how long it takes them to reach each other and to cover the 5,000 miles plus 1,000 X is equal to 5,000. So that is 3,000, X is equal to 5,000. And that means X is going to be, 5/3 hours, okay? And then you can convert 5/3 hours into minutes. Sorry, I did run out of space, so I'm gonna write it in the side here. We're gonna convert 5/3 hours times 60 minutes. And that's going to be 100 minutes. So that means it takes 100 minutes to travel 5,000 miles. Okay, so in order to figure out how far apart they are 1 minute before impact, you are going to do that 1 minute times the rate that it's going at, right? It's going at 5,000 miles per 100 minutes. And you should end up with 50. Okay, so that answer is A, 50 miles apart. Okay, let's see here. Okay, alrighty, we're gonna keep going. I must note, I do have to leave at 7:59 because I have a residency meeting at 8 p.m. But we're gonna try to go through this very quickly, okay? Okay, someone asked where 100 minutes is from. 100 minutes is the time that it takes them to travel 5,000 miles. Okay, number 76. We have a 10 by 10 by 10 cube made up of little cubes. You paint the outside of the cube. Okay, and it's red. How many little cubes have paint on each side? So you have this big cube, and on the outside, you're going to be painting it red. However, there's a set of cubes inside. I'm gonna try my best to draw this. There's a set of cubes inside that don't have any paint on them, right? So there's gonna be like the cubes on the outside, like the ones that are painted, are each gonna be one from that inner cube, okay? So that means that if you have this, if we're looking at a frontal view, this is going to be 1, 1, 1, 1, making that inner cube that doesn't have any paint on it 8 by 8, right? Because you take 10 and you subtract 1 from either side on the top and the bottom. And so you have the inner cube in blue is 8 times 8 times 8, which is 512 inside. And you know the volume of the big cube is 10 times 10 times 10, which is 1,000. And you can subtract them to figure out the ones that are painted, okay, or have any paint on them. 1,000 minus 512 is equal to 488. Okay. Alrighty. Number 77. How many 2 whole digit numbers are increased by 18 when their digits are reversed? So this again is one by trial and error. You can start with any 2-digit whole number. Let's start with 1 and 2. Okay. And when you reverse them, you get 21. Okay. And so the difference between this 21 minus 12 is 9. Okay. But we need the different, we need the difference to be 18. Okay. So we can try some other numbers. We can try 13 and 31. Okay. This difference, lo and behold, is actually going to be 18, which is great. Okay. And so then you will start to see a pattern. There's a difference of 2 between the digits. So this works with 1, 3, 2, 4, 3, 5, 4, 6, 5, 7, 6, 8, and 7, 9. Okay. And so that in total is 7 whole numbers. Okay. When you can double check them, right? You can do 42 minus 24. You can do 53 minus 35. And then that will show you that that difference is still 18 and these numbers all work. Okay. Number 78. All right, we have a teacher who announces that each day after the first, the class must do twice the total number of problems that had been assigned. The class.
Antalya, I just want to say you're finishing up the question, right?
I just started
already.
78.
I don't think we're gonna have enough time. You can try 3 minutes.
Do you
have
think
3 minutes?
Question.
No, right? You're not gonna make
I
it.
feel like not for this one, but what we can do for the writing tomorrow, I can begin with just finishing up. There's like 4 more questions left. Whatever you want. I can also just send out the notes too. So I have the answers written up for everything and they should be pretty clear.
Okay, how about we stop 8:05? Everyone, we're gonna stop 8:05. Okay, go ahead, Antalya. Just keep
Francis,
going. Okay,
I can't stop at 8:05 because I have a residency meeting at 8. Yeah.
Okay, fine. Everyone,
know.
bring Munchkin. Let everyone see the doggy. Come, bring Munchkin. Everyone, let's take a moment to type thank you into the chat box. Okay, everyone, let's type thank you into the chat. Okay, everyone, say thank you into the chat box. Okay, let's type it in. Hold on, I want to bring you Goldie. Goldie, Jessica, come bring me Munchkin. Everybody, I'm gonna show you. Who wants to see a cute little dog? Who wants to see a cute little dog? I want to say thank you so much. Oh, actually, Antalya, wait, make it chat for everyone. Sorry. Can you change the chat setting? Say thank you
Yeah,
to
yeah.
everyone. Oh my gosh, you guys are about to melt with how cute this dog is. Are you ready? You're all gonna melt. Hold on. I'm gonna start the video. Hello. Okay, you guys are about to melt over the cuteness. Goldie, come here. Come, Goldie. Come here. Wait, look at this, guys. I told her to come here. Wait, can you spotlight me? Hold on a second. Wait a moment, guys. Hold on. One moment. I'm going nowhere. Hold on. Look at this doggy. Can you spotlight me?
So cute.
Look at his face. Everyone say thank you. Everyone, look at this cute dog.
everyone.
What a cute little dog, huh? Jacob, look at what a cute dog. You want to show what a cute dog? Look at that. Say hi. Everyone, this is Jacob. Say hi, everyone.
Hi.
Say good luck on your test. Everyone's sick around me. What's going on this week? Say good luck on your test. Good luck on your test. I'm gonna bring you the doggy, okay? Let's look here. Look at the doggy. Who wants to see a cute little baby? Look at this little doggy. All right, Antalya, thank you so much. Look at this doggy. Say bye, Munchkin. Is the dog so look at this dog? She doesn't want to stay. Do you believe, Antalya, you've made it through 2 dogs at Queller Prep? So everyone
That's
type
true.
thank you.
That's true. Yeah,
Type
maybe.
thank you. Look at that cute dog. Look at that. Am I in spotlight? Oh my God, she does not want to stay in my hands at all. Can you take a moment? Look at this dog. Look at this dog. Look at how cute this little baby. You're such a cute little baby. Oh my God. This dog. Everyone, that's it. This dog is like, I do not want to stay with you anymore. Bye. Who wants to see another dog? Who wants to see a second dog? Who wants to see a second doggy? Ready? Jessica, come say bye to everyone. Come, honey. Jessica, look. Look, everyone. Who wants to see a cute dog? Say hi. Say good luck, everyone.
Good luck.
Good luck, everyone. Who wants to see Goldie? Goldie. Look at this face. Look at how cute this dog is. Oh no, these doggies. Goldie's like, nope, I don't want that. Everyone, wait. Oh, hold Munchkin. Let me. Can you, Munchkin, stay still. Antalya, do you believe it? You're 2 dogs in.
I am 2 dogs.
How
in.
many pounds
old
is this
now.
dog?
What'd you
1.5. 1.5 pounds. 7.5. One day they're gonna grow. Munchkin, say bye. Say bye, everyone. Jacob, say good night.
Good night.
Jacob,
Yes, you will
Jacob,
be
look, I want
getting
you to
my
go on the
notes.
camera.
You'll get
Go
my
on the
notes.
camera.
and
Go on the
these will be
camera.
neat notes.
Cute. Everyone. Look at how cute. Jacob, look at me. Look, I want you to say bye to everyone. Okay?
Bye.
Say bye. Hold on.
No, my.
Look at that face. Okay.
If you would like to reach me, anybody regarding tutoring, I saw someone in the
Yeah.
chat.
Oh,
you
yeah,
can
just
just
type
email
that
the Queller
info.
Prep email.
Can you type it in the chat box? info at quellerprep.com. Bye, everybody. Say bye, doggy. Say bye. Jacob, say bye. Bye.
His name is Munchkin.
Okay, guys. Is this your favorite part of the 2-hour webinar? Don't do that. Okay.
Okay,
Bye,
I actually
everyone.
have to leave.
Good
before-
luck on your
All right. Oh, that's
Thank
so. Oh
you.
my gosh. Oh my gosh. Wait. Everyone.
I have to go.
Say
I have to
thank
go.